There are two things that we don't know. What are they? Raise your hands. Okay, we don't know how much butter goes into each recipe. So how about P for pecan pie represents the tablespoons of butter for pecan pie. And M can represent the tablespoons of butter for mashed potatoes.
Butter for mashed potatoes?
That's the only reason why they taste good. Potatoes are very, very dry. So when you make mashed potatoes, you need some sort of like milk and butter to make them soft. If you're making them from scratch, if you make instant mashed potatoes, I don't really know how that works because I don't do that. Okay, it's just water. Yeah, I've honestly never made instant mashed potatoes. I make them from the real thing. Okay, so now we can set up two equations. Raise your hand if you know one of them. Colin.
3 equals mx.
Hold on. You don't know? What numbers are you trying to use? Okay, so let's try. She needs 17 she needs a total of 17. Okay, what equals 17? I need a total. That's a true statement, but I don't really care about that. What should equal 17? Oh, the total, P plus M, the tablespoons of butter in the pie, the tablespoons of butter in my mashed potatoes should add together for a total of 17. Okay. Now, I also know that there are 7 more tablespoons of butter in the mashed potatoes than for the pie.
So would we do P plus 7?
P plus 7 equals M. That was Avery's suggestion. Does that make sense? Who needs more butter? The mashed potatoes. So if we add the 7 to the pecan pie butter, that will equal the mashed potato butter. Because mashed potatoes need more, so I got to add the 7 to the one that's a smaller number. Interesting.
Isn't 8 tablespoons of butter like 2 cups?
8 tablespoons of butter is a half a cup. Yep. Because I bake.
Me too. I never make it.
So like if a recipe needs a cup of butter, that's 2 sticks. Okay. The World Cup game is starting.
Did it start an hour ago?
No, it starts right now. It starts at 1. There are 3 games today.
Yeah.
USA is the 3rd game. The coverage started at noon, but the game starts at 1. Okay, so now let's talk about how we're gonna solve this. I feel like this is set up perfectly for us to do what we did on Friday, isn't it? What did we do on Friday? Well, since M equals P plus 7, I can plug P plus 7 in for M, right?
Yeah.
Let's do it. P plus M equals 17. Yes, it is. Instead of M, I substituted in P plus 7, right?
You guys said P plus 7.
Yep. P plus M equals 17.
Okay.
You're not following?
Nope.
Look, M is P plus 7.
Oh, okay.
So P plus M.
I follow.
Okay. So now 2P plus 7 equals 17. This is great.
Wait, wouldn't that technically be 10?
Oh, so I can subtract 7 on each side? Is that what you're saying, Abby? So 2p equals 10. So p equals. Oh, interesting. How did I get that?
I got that like the very first step.
Now, if p equals 5, let's come back. P plus 7 equals m. Okay. Now, in this situation, do I want 5 comma 12 as my answer? Please don't do that. If it's a word problem, please answer it with words. Oh, no. Yeah, and can you put my magnet out? Thanks. So we need 5 tablespoons. I can't. What is my problem? Don't be annoying. Of butter for the, what is your problem? Oh, we have to write in math. Heaven forbid. But I now know that I need 17 tablespoons of butter. So I need over 2 sticks of butter. That's good to know. Okay. Cool. That's basically what we did on Friday, but we had to write the problem. Okay. So let's flash back to Friday real quick. Does anybody have questions on the homework from Friday? Oh, yeah. Number 8. Was number 8 tricky because of the fractions? Yes. Okay. So we have 3, 4. Okay. Can we agree that y equals y?
Yes.
Okay. So 3/4 x plus 1 equals 1/4 x plus 3. Do we agree?
Yes.
Okay. We need our x's to be together. So what we can do is we can subtract 1/4 x from each side, right? Amelia, what is 3/4 minus 1/4? 1/2. Are we okay with that?
Yes.
Yes.
Okay. So now what should we do? Subtract the 1. So 1/2 x equals 2. Okay, so how do we get x by itself?
Divide by 1/2 plus 1.
No.
Yeah.
Dividing by 1/2 is the same thing as multiplying by the reciprocal. So x equals 4. Is that where we went wrong? Yes. Okay. Now let's go back up to one of these. Let's go to the second one. Y equals 1/4 x plus 3. 1/4 times 4 is 1. So we get 1 plus 3, which is 4.
Wait, Miss Coleman.
Yes.
Well, like, I don't get it that you would have to multiply it. Because even if, like, if you look at that equation, 1/2 times 2 is still like 1.
Yes. So 1/2 times 2 is 1. We want 1x to equal something. That was the point. Kind of like if you have 5x equals 10 and we divide by 5, 5 divided by 5 is 1.
No, it's, wait, oh yeah.
Okay, the whole point is to get a 1 in front of the x. We just don't write it. So dividing by a fraction is the same thing as multiplying by its reciprocal. So dividing by 1/2 means the same thing as multiplying by 2/1. She's honest. So 1/2 x equals 2. Okay?
Yes.
If I said 2 divided by 1/2, like that looks confusing, right?
Well, like, yeah, but like obviously it's one.
Okay, so these cancel 1.
Yeah, and then x equals 1.
1/2 divided by 1/2 is 1. Over here, this means 2 times 2/1. Dividing is the same thing as multiplying. Keep, change.
Oh, no, I don't want to.
Yeah, buddy.
Amelia, you good? Okay. Okay, so this is what I want to have happen. Let's go back to this word problem page. I want you to go to the back side. Well, yeah, it's blank.
Go back to everything.
Okay, so I want you to write down this example. X plus y equals 7 and 4x minus y equals 3. Okay, we are going to solve this one by substitution. Now, let's talk about how this one differs a little bit from some of the ones from yesterday's homework. Okay, in yesterday's homework, we had problems where y was by itself or x was by itself, and we could do the substitution right away. Well, what if I give you a problem like this? That's not the case. So if I want to use substitution, what are we going to have to do? Not a lot. We're going to do the same thing we did on Friday, but we have one extra step. I can't substitute yet.
You have to put it into.
Okay, so I like that suggestion. The nice thing is we can pick. Do we want to make x equals? Do we want to make y equals? So first of all, let's look at the two equations. Which one do we want to pick to solve for a variable? The first or the second one?
I probably would do the second one.
I disagree. I think it would be way easier to take this first one and solve for a variable. Because look, I could say in this one, x equals 7 minus y. And I'm done. If I solve for x over here, I have all sorts of fractions. Okay, so what did I look for? I looked for one of these that had a coefficient of a +1, and I solved for it. If you're not writing this down, you're not doing what I'm asking you to do. If you have something other than a pencil in your hand, or a pen, because Andrew likes to do math and pen. Okay, so now what can we do? I can say, all right, x equals 7 minus y. Well, if x equals 7 minus y, I can take 7 minus y and punch it in right here for my x. So 4 times x. Now remember, I need to put that in parentheses since it's being multiplied to the 4. Okay. Sorry, I just really need a drink of water. So now we have 28 minus 4y minus y equals 3. Okay, negative 4y minus y. Okay. And I need to solve for y. So what should I do to both sides? Yeah.
Wouldn't you subtract the other y though? Because, like, wouldn't it be 3y?
So negative 4y minus 1y.
Oh.
Don't laugh. She is not the only one who had that question. And because she asked, somebody else also has the answer. There are no stupid questions. Apparently just rude classmates. Reagan, what do I need to do to both sides? Let's subtract 28 to both sides. So negative 5y equals. Ooh, that's nice. Seth, what does y equal? If negative 5y equals negative.
I also disagree. I believe it is y equals 5.
Okay, are you okay with y it's positive 5? Okay, so now let's take this back up to here. If x equals 7 minus y, and we know that y is 5. Okay.
And then those are our coordinates.
2,
5.
comma, 5.
Good math.
Sorry, whoever I just knocked over. Okay, so let's check, right? We always know if we have the right answer. 2 comma 5 is 2 plus 5 equal to 7.
Yes.
Is 4 times 2 minus 5 equal to 3.
Yes.
That's awesome.
Stop being a rude classmate.
Well, now you are.
I'm asking her to stop.
I'm not.
Okay, write this one down. Okay. Technically, there are 4 different ways we could use substitution for this problem, but only 2 of them are nice. Stop playing with my markers. To your neighbor and talk about how you would start this problem if we were going to solve with substitution.
How would x equals 12 plus 3y?
Minus 3y. Okay, eyes up here. Gavin, what would you do? Okay, so Gavin said I would pick the first equation and make x equals 12 minus 3y. Who said something different? Everybody said the exact same thing.
I said plus 2.
Okay, and then we're wrong, and so then that was embarrassing. It wasn't embarrassing, because it's okay to make mistakes.
It was inspected, corrected, respected, and expected.
Thank you. That was a great opportunity. Nobody said I would take the second one and say y equals 9 minus 2x. Could you do that? Okay, so you did negative 2x plus 9?
And the same for like the top one.
Okay, so you only have to pick one, all right? So what's nice about this problem, I'm pretty much telling you there's two different ways you could go about doing it. You could solve for x here and have a nice substitution. You could solve for y here and have a nice substitution. So let's vote. Who wants to solve for x in the first one? Raise your hand. Who wants to solve for y in the second? Okay, the class has spoken. Let's take this one. X equals 12 minus 3y. And so we're going to take that and we're going to plug it in for x in the other one. People, if you plug it into the same one, you're going to get some funky things happening. Don't do that. Plug it into the other one.
How did you like that? Could you solve for y?
I subtracted 3y.
Oh.
So actually solving for, yeah, that would be fine. Like in the top one. So you would have y equals negative 1/3 x plus 4. And then you get to work with fractions. Do you want to do that, Reagan?
No.
I don't really either. So that's why my suggestion is if you have a variable with a coefficient of +1, that's a good one to solve for. Okay. I would not solve for one that has a coefficient of not +1 unless you don't have a choice. Do you have a question or a stretch?
No, just.
Okay. She has a stretch. All right. So 2x. So I'm going to plug 12 minus 3y in for x. We get 24 minus 6y plus y equals 9, unless you disagree. Did I do something wrong? Good there? Okay. This is where we're at. So negative 6y plus y. Do you see what I mean?
So when you add it,
Mm-hmm.
would it be negative 5y?
This time we're getting negative 5y. Yeah.
Okay.
Okay. So we have 24 minus 5y equals 9. Preston, what do I need to do to both sides? Subtract 24. And we get negative 5y equals negative 15. Yeah. Yeah. Okay. So Peyton W, what is y? Y equals 3. Positive 3.
Wait, divided by negative.
So and a negative divided by a negative is a positive.
Oh,
Yeah. Okay, so now we're going to bring 3 back up here. X is 12 minus 3y. No way. Is X also 3? Oh my.
Oh my god.
Okay, Seth, since X is 12 minus 3y, I brought my 3 up here to the y, and I have 12 minus 3 times y. Let's check, make sure our answer's right. What is 3 plus 3 times 3? Good. 2 times 3 plus 3. Wait, what?
18. Wait.
2 times 3 is 6, plus 3 is 9.
I know, but it would be 3 plus 3 times 3.
So 3 plus 9?
Oh, sorry. I thought that equals 6.
You are adding instead of multiplying. So many things. So many things.
I can't judge.
Okay, I am going to give you 2.5 minutes to see if you and your elbow partner can set up and solve the second problem.
Yeah. So.
Did you break the piggy bank or open it from the bottom?
It's you. What would you have done? Okay. I don't know. Why are you playing with my scissors when you should be doing this problem? Well, you should be doing it with your elbow partner.
Whoa.
How do you not have any?
I think you're gonna have
And it equals $2.
Okay, as I'm looking around, I see somebody with n plus q equals 16. I think that's a good one. If you're gonna set something equal to $2, it probably should have some money attached to it.
What?
I don't think so. 5 cents. Okay, I'm gonna just have to stop you right now. This is making me a little bit nervous. I'm getting some questions that I didn't think that I would have to answer. Nickels are worth 5 cents and quarters are worth 25 cents. So 0.05 times the number of nickels plus 0.25 times the number of quarters equals $2. There you go. Let's solve this right here. I put the second one up for you.
Can I convert it?
Sure. Sophia had a great question. Could I do this in pennies? Sure. If you want to write 5n plus 25q equals 200 pennies, go for it.
Nickels and quarters though.
Yeah, but it's the answer. And so the decimal, you just work with whole numbers.
So she's saying, can I do 5n plus 25q equals 200?
I'm so confused.
Very.
Oh wait, I know.
Okay, what did we do on the back side? Take this guy. And say, okay, don't be confused. You're fine.
I didn't.
What? Wouldn't it be 16 minus 2?
Maybe that's no.
I'm gonna give you one more minute. A nickel is worth 5 cents. Okay, so just like we did over here, like we rearranged this to be x equals 7 minus y, right? You could do that with this equation right here.
Whoa.
What's the other equation?
Pick n or q.
Hey,
Okay, eyes up here.
Why do you need a calculator?
Eyes up here. Is there a variable with a coefficient of a positive 1? There's 2 of them.
Yeah.
One N and one Q. So let's take this guy and solve for one of the variables. Preston, which variable did you solve for? You wrote that N equals 16 minus Q. And then we can take 16 minus Q and plug it in for N, right? So 0.05 N plus 0.25 Q equals 2. Ooh, what is 0.05 times 16? 80 cents? Minus 0.05 Q plus 0.25 Q equals $2. What's the problem now? You're using your calculator to help us out, right? That's what you're doing? Okay. That's what I expect. Nothing else. Okay. What happens when I combine these two? $0.20 Q. Negative 0.05 plus positive 0.25 is a positive 0.2. What? Okay.
Do you have a question? It's okay.
What's your question?
No, no one will laugh.
It's just
at you.
confusing.
That's-
Oh, but this is gonna work out so nice. If I subtract 80 cents from each side, I'm left with $1.60 over here. And if I divide $1.60 by 20 cents, hey, and with his calculator over there, what do we get?
It should be $1.
Oh, man. So now what is it? 6. That was my fault. And then we can take Q equals 6 back up to here. I'm out of room. If N equals 16 minus Q, then N is, what do we have? We have 6/4 and 10.
I counted on my fingers.
Okay, so can I set an expectation here?
Yeah.
I think it's really super awesome that you can guess and check to get some of these answers. Okay, kudos to you. But since I am trying to understand your mastery of solving systems of equations, I really would like to see the setup of the equations and the work. So I know that you understand how this process works. Okay, on like a multiple choice situation, on like a standardized test situation, count on your fingers all you want, okay? But I need to understand your mastery. So your homework is that next page, page 141 in your student journal, 10 through 19. So I would like you to get number 1 done before you walk out of here. Not number 1, number 10, which is the first problem, but you know that. You know what I mean. 10 through 19. Okay.
This pen?
Yep.
Oh, no.
Hey, Preston, could you change that to a 19 instead of 18?